Hello, and welcome to today's algebra lesson. This is the first of three parts where we'll talk about the slope of a line. In this first part, we talk about how to calculate it. In the second part, we'll talk about slopes of parallel lines. And in the third part, we'll talk about slopes of perpendicular lines. Now, a line is the most basic function, and pretend that's straight. The neat thing about a line is it's at a steady pitch or a steady rate of change. So if I pick any two spots in the line and calculate the pitch, or the angle of elevation is another way to look at it, it will be the same. So that's what we're going to be looking at today. And I need to shut that off. Okay, so slope. Many of you have seen this before. Many of you have heard the words rise over run. The slope of a line is the rise over the run. It is how steep the line is. Some lines will be really steep, and other lines will be flatter. Some will go in the other direction. All of that can be calculated with a number that we call rise over run. We call that slope. It's abbreviated with an M, probably from the fact that mountain begins with the letter M and mountains have slope. It's some sort of a derivation from the French culture, but M is used to represent slope pretty universally in mathematics. The biggest issue students have with this is they mix up. They do it upside down. It is rise over run. It is not the other way around. So, when the rise over the run, that ratio is positive. Either the number on the top and bottom are both positive, or the numbers on the top and bottom are both negative. It means your line is going this basic direction. In math, when we analyze graphs, we often look at moving from left to right. So as I move from left to right, I'm going along, and I'm going uphill. That is a positive slope. Now, if I'm moving from left to right and I'm going downhill, that's a negative slope. That happens with the rise and the run have different signs. Either the top is negative or the bottom is positive, or the top is positive and the bottom is negative. So here is what we mean by rise over run. Here's a line. The rise is from, so we're looking at these 2 points. And this would work, and I'd get the same numbers if I picked 2 different points on this line. But I've picked these 2 points. This first point here is x1, y1. And the second point is x2, y2, if I write them as an ordered pair. So the rise is the change in the y's. How much higher does it get, divided by how long horizontally it took to get that high. The run is the change in the x's. So the y is y2 minus y1. That's the rise. Then the run is x2 minus x1. I'm going to recommend you calculate them in that order, because what happens is students tend to start with the x, and then they give me run over rise instead of rise over run. You don't want to join the upside down slope club. That's no fun at all. Their meetings are really boring. Okay? So you want to calculate the change in y's first and then the change in x's first. So you would have the coordinates for this point x2, y2. You can read them off a graph, or maybe they were given to you directly. And the coordinates for this point x1, y1. You're going to take the y coordinate of this point and subtract the y coordinate of this point. Then you're going to take the x coordinate of the same point you started with the y's and subtract the x coordinate of the second point. Now, it actually doesn't matter. If you do y2 minus y1, you can see y2 is higher than y1. You're going to get a positive number. And x2 minus x1 is a positive number. So you get a positive slope, and we can see this goes uphill, which is a positive slope. If nobody defines for you which point is 2 and which is 1, you just are given 2 points. If you did y1 minus y2, you would get a negative number. It would be the same number, but it would be the negative value of y2 minus y1. That's okay if you start that way, as long as then you also do x1 minus x2. That will be a negative number, and you'll have a negative over a negative, which is still a positive. So which point you call point 1 and which point you call point 2 doesn't really matter. As long as if you start calculating your rise by using this point here, and you do y2 minus y1, you must also start calculating your run using the same point and do x2 minus x1. If you started calculating your rise by doing y1 minus y2, started with this point here, That's okay as long as in the denominator of our slope, or the run part, you also start with the x value of this same point and subtract that x value. Otherwise, if you don't keep the order right, you will get incorrect signs as a minimum in your answers. All right, so if we're given 2 points, we call, so the first point could be some number. The first point could be, say we had 3, 6. And then we had another point, -1, 4. You're just given those 2 points. So this 3 is the x-coordinate of one point. This 6 is the y-coordinate of the same point. It doesn't matter whether you call that 1 or 2, but if this one is x1, then its y-coordinate is y1. If this one is, so in the next point, x is the one on the left, so that's all you know, that's going to be an x. If this is x2, then this is also y2. And now you have y2 to plug in there, y1 to plug in there, x1 to plug in, x2 to plug in. So labeling these will keep you from making the mistake of making this x1 minus x2 when you had y2 minus y1 there. Now, I could have labeled this point x2, y2, and then this one x1, y1. It wouldn't matter as long as I put them in the formula in the correct place and kept track of my signs correctly. Now we say x2 minus x1 not equal to 0. That's because we can't divide by 0. It turns out if x2 and x1, when you subtract them, 0, means they were the same value. When you subtract something from itself, you get 0. And you would have had this case where you had a vertical line. The x's it doesn't go left or right at all, it just goes up. And we would say that has an undefined slope. So if you get this division by 0 and you get an error in your calculator, or you see you get a 0 on the bottom and know you can't divide by that, then you know you have a vertical line. We'll talk more about that later. If you get a 0 on the top and a different number on the bottom, and some number on the bottom, 0 divided by a number is 0. In that case, if y2 and y1 are the same, you get a horizontal line. We'll talk more about that later too. Okay, so again, here's our formula. You must remember this. Rise over run. Rise is the change in y. We find that by doing one y-coordinate, the y-coordinate of one point, minus the y-coordinate of the other point. Run is the change in x. We go back to the same point we used for this number here, but take the x-coordinate and now subtract the x-coordinate of the other point. Do those 2 steps, and then make a ratio, and that's your slope. And you can reduce that. We usually leave slopes as fractions, as reduced fractions. You can reduce them in your calculator or reduce them any way you know how. So it doesn't matter which point you call which, and I keep saying this. That's what I've said over and over. Now let's do an example. Students like examples typically. So find the slope of the line passing through the pair of points, then explain what the slope means. So here's your 2 points, -7, -8, and 4, -2. Usually I just take the first point and label it x1, y1. So x1 is -7. y1 is -8. x2 is going to be 4. I'm sorry, I should have written it over here. x2 is going to be 4. And y2 is going to be -2. So I'm going to do this minus that for the top. And then I'm going to go back here again, this minus that. The more you write out, the less likely you are to make mistakes. Okay, so when we see that below, I have y2 minus y1. Now you have to be really careful of your signed number arithmetic. That's the other problem students have. If students are good to never do this upside down and put the, if they put the y's on the top and the x's on the bottom and they keep their order right, the bigger issue we have is signed number arithmetic. You want to put your negative numbers in parentheses. As a matter of fact, I would recommend just put everything in parentheses if it gives you less. So, here's parentheses here and here. You're going to put your y2 in this parentheses, your y1 in that parentheses. There's always a subtraction between them. You're going to put your x2 in this parentheses, your x1 in this parentheses. There's always a subtraction between them. So I get -2 when I subtract a negative. Subtraction is the same as you turn it to addition and then change the sign. So some of you learned to do this, but if you change subtraction to addition, you just change the sign of what you were subtracting. It's the same thing. -2 plus 8 The signs are different, so I subtract 8 minus 2. I keep the sign of the bigger one. I get a positive 6. And on the bottom, 4 minus a negative 7, again, becomes 4 plus a positive 7. And the signs are the same, so I just add them. So on the bottom, I get 11, and that is my slope. There's no need to say, oh, that's a funny looking number. No, it's a ratio. It's a fraction. They are fine, allowable numbers in algebra. So you have to be careful with several things. None of this is difficult. It's just being very careful that matters. So I found 6/11, so here's the calculation down out again on the slide. What it means is that for every 6 units the line goes up, it travels 11 units to the right. So if I have a line that goes like this, and I don't know if I can change the color here. I'm still learning how to use this. Let me see if it'll let me change colors. Oh yeah. And I do this. Oh, it erased my line. I'm sorry. So I'm going to go up 6 units. If I go between these 2 points, the difference in this height will be a 6, and this will be 11, if these are the 2 points I used. Okay? So if I want the slope between these 2 points, I found that the difference in the y's, which is right here, and if you had your y-axis over here, you would see this y2, this y1, is 6, and the difference in the x's, I haven't drawn these points in the correct place for the problem, but just to get you the idea, the difference in the x's, there's your 11. Rise over run. Let's go on to the next slide now. Now, to show you what I mean, that the order doesn't matter, in our last example, we used these same 2 points, but I called -7, -8 was x1, y1, and 4, -2 was x2, y2. So what I'm doing here is, this time, x1 is 4. That's supposed to be x1, and y1 is -2, and x2 is -7. Sorry, I don't know why that's not liking me now. y2 is -8. So you see I put the -8 in down here, and I subtracted the -2. So -8 minus a -2 becomes -8 plus 2. The signs are different. Subtract 8 minus 2 is 6. Keep the sign of the bigger one, which is the 8, so I get a -6/11. And then in the bottom, my x2 was -7, and my x1 was 4. -7 minus 4 will give me, the signs are the same, so I add and keep the original sign. I get -11. So what you see here is I get, at first you might thought, I get -6. It's going to be different. No, get -6 divided by a -11. And it's basically like you factor a -1 out of each of these and reduce them. A negative divided by a negative is a positive. So that's why the order doesn't matter, is if you switch the order of the 2 points, you switch the order of the subtraction of both the top and the bottom, and you still come out with the same sign in the end, and the same numbers. But you have to do the arithmetic carefully. All right, so here are the possibilities for slopes of lines. Again, we talked about this goes uphill. This is a positive slope. This is downhill. It's a negative slope. This slope of 0, a horizontal line, this happens when the y is the same in both points. So y is always whatever that number is. You'll see more about that later. Sorry, I'm trying to draw with the mouse here. And here, this happens when the x values are the same. Sorry, x the same. So that's what happens there, okay? 0 slope is when you get a 0 on the top of the fraction for slope. Undefined slope is when you get a 0 on the bottom because you can't divide, and that gives us a vertical line, and the equation of this would be x equals a number. The equation of a horizontal line will be y equals a number. Okay, let's move on to another example. So here are 2 different points. Find the slope between these points, 4, -2, -1, 5. I label my points x1, y1, x2, y2. So I take y2 minus y1, and you could even do these separately before you make the fraction and then make the fraction if you have trouble seeing all of this at once. So I have 5 minus a negative 2, which will give me a positive 7. And then because I started with the 5, I have to start with the negative 1 on the bottom. Negative 1 minus 4, negative 5. Now in a fraction, if one of the top or the bottom is negative, it's the same as saying the number itself is negative. Or it's the same as saying the negative 7 over positive 5. It doesn't matter. If you switch the order of these points, you would have gotten a negative 7 over a positive 5, and it's still negative of 7/5. If there's one negative in either the top or the bottom, you can write it out in front. Your slope is negative in this case, and that means the line falls from left to right. And here's one more example. Okay, 6, 5, 2, 5. What I notice right away when I look at these, sometimes making observations helps, the 5s are the same and they're both y. So see what happens. I get y2 minus y1 is 5 minus 5. And the x is giving something, but I have 0 divided by 4. Students have a hard time remembering, oh, is that the one that's not defined or is it 0? You could always do it in your calculator. If your calculator tells you 0, the slope is 0. If your calculator tells you undefined, then the slope is undefined. If it was negative 4 divided by 0, it would be undefined. But 0 divided by a number is okay. That gives you 0. And you're going to see that this gives us a horizontal line. And what's going to happen is when you go to graph that, if you graph those 2 points, if you're confused, you get this and you're supposed to find the equation of the line, graph the 2 points. 6, 5 would be like around here somewhere, and 2, 5 would be like around here somewhere. So you can see that this line is going horizontally across. And what's the way you know the equation is, if you get this horizontal case, you don't get x in the equation. It turns out no matter what x is here, y is always 5. So the equation of that line is actually visible from the points. Sorry, I'm still trying to figure out how to write with this. There we go. Okay, so that's another example. That's an example of one of those different ones where you have a horizontal line. And let's see, we may be just about done here. Oh, one more example. Now I did a horizontal line. You can see in this one, the point 1,6 and the point 1,4, the x's are the same. So when I find my change in x, I get a 0. So I end up dividing by a 0. And you can see the calculation done out. If you want to look at it more carefully, you can always stop the video. I get negative 2 over 0. If I do that in the calculator, I get an error or some can't divide by 0. That means the slope is undefined and the line is vertical. If I were to graph these 2 points, I want to graph. One would be at 1,6 and one would be at 1,4. And they would be right above and below each other. And what would happen is this would be my line here. And draw that both directions. I get a vertical line. A vertical line has undefined slope. You can plot if you're asked to draw the line x equals 1, just make up 2 points where x, the first coordinate is 1 in both of them, and just put 2 different y coordinates, and it'll show you the direction of the line. Okay, that's all we have for calculating slope, and those are the 4 ways it could come out: positive, negative, 0, or undefined. You should be able to go and start those homework problems now, and I'll see you next time.